Section 8.4 is compositions of isometries. Our goal is that given a geometric figure and a rotation, reflection, or translation, we can draw the transformed figure and specify a sequence of transformations that will carry a given figure onto another. On page 532, we have in the Solve It, you looked for a way to use two reflections to produce the same image as a given horizontal translation. In this lesson, you will learn that any rigid motion can be expressed as a composition of reflections. The term isometry means same distance. An isometry is a transformation that preserves distance or length, so translations, reflections, and rotations are isometries. You can express all isometries as compositions or reflections. Expressing isometries as compositions of reflections depends on the following fact. The composition of two or more isometries is an isometry. There are only four kinds of isometries: translation, rotation, reflection, and glide reflection. You will learn about glide reflections later in the lesson. On page 533, we have in lesson 8.1, you learn that a composition of transformations is a combination of two or more transformations, one performed after the other. A composition of reflections across two parallel lines is a translation. You can write this composition as the reflection over line M of the reflection over line L of triangle ABC is triangle A double prime, B double prime, C double prime. Or the reflection over line M of the reflection over line L of triangle ABC is triangle A double prime, B double prime, C double prime. And line segment A double prime, B double prime, and C double prime are all perpendicular to lines L and M. So here is A double prime, B double prime, and C double prime. If we were to sketch these line segments, they would all be perpendicular to lines L and M. Example 1 says, what is the reflection over line M of the reflection over line L of J? What is the distance of the resulting translation? So to do this, we start with the inside transformation, which is the reflection of J over line L. So we're going to take J and reflect it over the first line here, L. We can start by labeling the letter J with a point that we can call point P. Then we can mark a point A on line L so that the line segment PA is perpendicular to the line L. Now we are going to reflect our figure, the letter J, over the line L to get this backwards looking J, which will be at point P prime, such that the segment PA is congruent to the segment P prime A. So these two distances will be equal. Since PA is equal to AP prime, we have that PP prime is equal to 2AP prime. So here is PP prime. We know that these two segments are going to be congruent. So PP prime is going to be the same as AP prime twice, because these two will both be equal to the length of AP prime. Now we are going to take this reflected figure and reflect it one more time over the line M. When we reflect our already reflected figure over line M, we'll get this blue figure that is at point P double prime, and we'll use the point B on line M such that the line segment P prime B and BP double prime are congruent and perpendicular to line M. Therefore, since P prime B and BP double prime have equal lengths, we have that P prime P double prime, which would be the length from P prime to P double prime, is going to equal 2 P prime B. So here's P prime B. Since we know this length is equal to this length, we can say that this entire length from P prime to P double prime is just 2 P prime B. Therefore, the total distance of the resulting translation is 2 times the length of line segment AB. Because we have that from P to P prime was 2AP prime, which is right here, and from P prime to P double prime, it was 2P prime B, which is this length right here. So double this length plus double this length would give us double the entire length from A to B. So the distance of the resulting translation is just twice the distance between lines L and M. The work for this problem is written out on the next slide. And now I would like you to try homework number 1 on page 534.